So we are still in section 7.5, and I want to finish up this section by going back and looking at 5 part D and then doing example number 11. So in 5 part D, I like all the things that the author did, but I'd just like to share a possible different way. It's how I like to do these, starting right here where it says you've got the sign and there are some restrictions. And so the sign has to be, that it's alpha, has to be between pi over 2 and pi. So I'm going to go ahead and draw that alpha has to be between pi over 2 and pi. So alpha is going to be over here. And if alpha is going to be over there, and it said sine of alpha is 4/5. Sine of alpha is 4/5. Sine is the ratio of y over r, so that means it's going to be 4 over 5. There's a thing called a Pythagorean triple, so we could go ahead and do the Pythagorean theorem on this triangle, and we're going to get the same answer there's a shortcut. And so the shortcut is there is a Pythagorean triple. And anytime you got a 4 and a 5 and the 5's in the hypotenuse, just put a 3 down. You can go ahead and solve the theorem if you want to, but it's going to be a 3, 4, 5. The only thing I have to be aware of is that because I'm in that quadrant, I have to make it a -3. So my alpha's done. Now I'm going to move to beta. So looking at beta, beta is between pi and 3 pi over 2. So beta is between pi and 3 pi over 2. So beta is down here. And they give us beta as a -2 over square root of 5. But then they also rewrite it a little bit for us. And since I've already got, well, let's see what happens. One of these is going to be x, because sine of my beta, is it sine or cosine? Sine of my beta. So they wrote it this way, but it needed to be rationalized. So they went ahead and rationalized and said it's -2 square root of 5 over 5. Well, let's go ahead and use that one. Sine again is going to be y over r. And so this is my y, this is my r. And then this one, yay, there's the negative. And this one, it's not a cute Pythagorean triple. I'm going to have to go ahead and work out some of this. So to work out this using the Pythagorean theorem, I'm going to take the fact that I don't know my x squared. I need it to add it to my y value squared. And then it's going to equal my hypotenuse squared. With that in mind, we just need to keep working on it. I'm going to get a 4 times a 5. So I'm getting a 20 because we needed to square that. Oh, I'm sorry, because it's squared, we have the 4 times the 5. And then my 5 times my 5 is a 25. So we will subtract, and then we will square root plus or minus 2. So looking here, I need plus or minus 2 because of where I am in the quadrants. It's going to be a -2. And now I've got my 2 pictures, and from there I can compute anything they want me to compute. So one thing they want me to compute, and all I'm going to do is part D. D wants sine of alpha plus beta. And for alpha plus beta, again, we have noticed that we have the chart. When we're dealing with sine, we do sine cosine, keep the sine, cosine sine. And a reminder on the cosine, it's, well, you've already seen them. So here we go. So in this case, I'm going to need to do sine of my alpha, and then I'm going to need to do cosine of my beta. I get to keep my sine, my plus, and then I'll do cosine of my alpha and sine of my beta. Well, I already have my drawings. I already know what they are. I know they're all 3 of their sides, so I just need to fill in the blanks. If it wants sine from my alpha, I can go back to my original, which I should. I'll go ahead and check. It is 4/5. And so I have 4/5 for sine of my alpha. I now need cosine of my beta. So I go over here to beta. To do cosine of beta, I need -2 over 5. That's part of that SOHCAHTOA. Now I need cosine of alpha. When I go over here for cosine, my cosine's my x over my r. And then finally I need sine of my beta. Here's my beta. My sine's going to be y over the r. So that's a -2 square root of 5 over 5. I like this. I feel like it's a bit faster drawing the pictures, labeling them very quickly, using Pythagorean if we need to, filling in the pieces and parts, and then we go do numerators times denominators, and then we do numerators times denominators, and then depending on what they want you to do inside of MyLab Math, that could work. We could always go ahead and put them over one denominator, and then how you write it's going to be up to you. Do you want to do the minus 8 plus the 6 square root of 5, or do you want to do the 6 square root of 5 minus 8? And on a test, it's not going to matter as long as it's not reducible, and as long as you don't put these two together. You cannot put these two because the 8 doesn't have a square root of 5, so this is the best that you can do. So that was a quick look at 5D. We're going to finish up this section, and we're going to go look at 11. So looking down, where is it? Right there. So looking here at 11. 11 is a solve an equation. Well, that's new and different for this section. But to solve this equation, we are very happy that they have blocked us in to 2 pi, or from 0 to 2 pi, and we can include 0. And so when I look at this, I've been doing a bunch of identities. I've got all of my identity stuff rolling around in my brain. I've got reciprocal identities, Pythagorean identities. I got a whole lot of stuff rolling around in my brain. And when I look at this, I really, really wish it was sine squared plus cosine squared, because that would just be amazing. But it's not. But you need to remember, we can square both sides, and that's a legal move. So if I square both sides, that means I've got sine theta cosine theta times sine theta. And I write it like this because a lot of students will mess up if they just put parentheses and square. They end up with just 2 terms. We're going to end up with 3. And then I need to square my 1, and 1 times 1 is 1. So when we do our first, outers, inners, and lasts, I need to go ahead and write that down and see what we got. So when I do the first, I get sine squared theta. Ooh, got my sine squared. When I do my outers, I get sine theta cosine theta. When I do my inners, and I should have started this way over there. When I do my inners, I get cosine theta sine theta, but I'm going to go ahead and write it sine theta cosine theta because multiplication is commutative. And then plus, and sorry about the wrapping around, cosine squared theta. And all of that's supposed to equal 1. So all of this is on the left-hand side, and so let's clean it up. This isn't an identity where we're like, okay, where am I going? We're trying to solve. We're trying to say the theta could be. And so I got to keep dragging this 1 along, but one thing I notice is that I have a sine squared plus a cosine squared. Well, I can change that to a 1 real fast. Now I've got 1 of these and 1 more of these, and that means I got 2 of these, and so I got 2 sine theta cosine thetas, and all of that equals 1. Remember, we're trying to solve. And by the way, if I'm going too fast, and I just found out the other day, you can speed up the video to make me go faster. But if I'm going too fast, hit stop, and then let your brain think on, ruminate, really soak in what's going on, and make yourself some notes and even flashcards. When I'm looking at this, I know that I could move the 1 over, and I'm going to get 2 sine cosine, oh my gosh, equals 0. And I can divide by 0, oh sorry, divide by 2, which that's going to give me a 0. And what we've done before is you have a product here, and it equals 0. And when you do, you set each factor equal to 0. So my sine of theta could be 0, or my cosine of theta could be 0. Well, what that means is my theta I'm looking for is the inverse sine of 0, or my theta over here that I'm looking for is the inverse cosine of 0. And so let's start thinking of all of the possibilities where sine The answer was 0. Sine is based on y, so where is the y? 0. And when I'm looking at my quadrants, y is going to be 0 over here at 0, and y is going to be 0 over here at pi. So two of my answers could be 0 and pi. Well, let's look at cosine. Where is cosine going to be 0? It's going to be 0 where the x is 0. And so two answers coming from this part could be pi over 2 and 3 pi over 2. So those are all of my possible answers, but warning, warning, warning. As soon as you start squaring something, you are greatly manipulating an equation. And when you start to greatly manipulate an equation, you can create some extraneous answers that are not really true to the original equation. So I now need to take my 0 from down here, and I need to plug it back in here and do sine of 0 plus cosine of 0, and does it really turn out to be 1? Then I need to do pi over 2. I need to do sine of pi over 2 plus cosine of pi over 2. Does it really turn out to be 1? I need to check all 4 of these, and here's how we're going to check them. We're going to go to the very bottom of that page, and we're going to look at the bottom of page 494. And at the bottom of 494, they've already done it for us, and for the sake of time, and there we go, I'm not so blurry. They checked 0, pi, pi over 2, and 3 pi over 2, and notice we had some that were solutions and some that were not. And so our final ultimate answer for example 11 is only 0 and pi over 2.